Welcome, my friends! The slope of a line measures how steep that line is. A line that moves upward from left to right has a positive slope. A line that moves downward from left to right has a negative slope. A horizontal line has no steepness and therefore has a slope of 0. We classify a vertical line as having an undefined slope. If we are given the graph of a line on a coordinate plane, we can calculate the slope. We know the slope of this line must be positive as it moves upward from left to right. There are 2 points that are clearly identifiable from this line, which are all we need in order to calculate the slope. Colloquially, slope can be thought of as the rise over run, meaning if 2 points are identified on the line, the slope is the vertical distance between them, the rise, divided by the horizontal distance between them, the run. In this example, we must rise 3 units from the first point to be level with the second point, so our rise is 3. Then we must move horizontally 4 units to the right to reach the second point, so our run is 4. Altogether, our slope is the rise over run, or 3 over 4. Here's another example. We know the slope must be negative as the line moves downward from left to right. Starting at the leftmost point, we must move down 5 units to be level with the second point, so our rise is negative 5. Then we must move 3 units to the right to reach the second point. Therefore, our run is 3. Altogether, our slope is negative 5 over 3. You may be asked to find the slope passing through 2 points without a picture of the graph, as we have here. One way to solve this could be to draw the graph and create the line that connects the 2 points, but a more efficient way is to use the slope formula. We have already stated that slope is equal to rise over run. Another way to think of rise is the change in y values on the graph. How far we went up or down is how much y changed, and therefore can be thought of as our rise. The way we write this is y2 minus y1, meaning subtract the y coordinates of our 2 points. Another way to think of run is the change in x values on the graph. How far we had to move to the right in order to reach our second point is how much x changed, and therefore can be thought of as our run. The way we write this is x2 minus x1, meaning subtract the x coordinates of our 2 points. Putting it all together, the formula for slope, sometimes notated as m, is y2 minus y1 divided by x2 minus x1. Now let's apply our slope formula to this problem. We are given 2 points, negative 3, 7, and 2, negative 6. You must choose which point will be point number 1 and which point will be point number 2. It doesn't matter which point you choose, so the easiest way is just to let the first point listed be point number 1. Recall that when we see an ordered pair like this, the first number is the x value and the second number is the y value. Therefore, negative 3 is x1, 7 is y1, 2 is x2, and negative 6 is y2. Now we are ready to plug into the formula. Slope, or m, is equal to negative 6 minus 7 divided by 2 minus negative 3. Make sure to include parentheses in the denominator as we are subtracting a negative number. Negative 6 minus 7 is negative 13, and 2 minus negative 3 is the same as 2 plus 3. Therefore, our slope is negative 13 over 5. We can verify this method works by looking at the graph of the line. I have our 2 coordinates plotted with a line connecting them here. The vertical distance from the first to the second point is negative 13, which is our rise. The horizontal distance between our 2 points is positive 5, which is our run. Notice that we get the same answer. y2 minus y1 is the rise of negative 13, and x2 minus x1 is the run of 5, giving us the same slope of negative 13 over 5 when we divide. Amazing! Alright, my friends, That completes our video introducing the slope of a line.